Today we are diving into service dependency mapping, what it is, why it matters, and how it can make your life easier. My name is Stefan. I'm a sales engineer at Mugato, where we help enterprises to understand their infrastructure and their application services much better. What is the definition of service dependency mapping? It actually means the automated process of discovering and visualizing the relationships and the dependencies between IT services, applications, infrastructure components, and business processes within your environment. And what we do at Mogato is that we provide that map always up to date on a current basis. It tells you what you have running. So all your applications, servers, databases, and services. It tells you how everything is connected, which systems talk to which other systems, and it tells you what depends on what. So if a server goes down, what application would stop working? What we see here is such a map. Let's take one example and focus only on this in order to understand what other application services consume capabilities of that service. And we see it's a couple of applications. And what we can also see is what are the real dependencies. So what I just did is I drilled down into that specific application service, and we now see that this service actually consists of two servers, and that gives us some interesting insights because we would now know what will happen if, for example, we're going to shut down this machine for maintenance, for example. And this is an example that I've seen quite a lot of times where you have a service that is supposed to be redundant according to the design. And you go to a CAP meeting, you ask for approval for a shutdown. And the question, what will be the impact, will always be answered by there's no impact because it's redundant. And in that case, there's a second mail server who could take over. But if you look closely, you will see that the usage of both of the infrastructure components is not evenly distributed. That might indicate a configuration failure of these application services. In any case, it would already give you an idea about an issue and about incidents that might occur after you decided to shut down that particular machine. The use case we just talked about is probably the most classical one. It affects IT operations and it tells you what will happen if you shut down a server, what application will be impacted. But in a similar way, it will also help projects to execute in time. Let me give you an example. Let's assume that you set up a project to consolidate servers and to get rid of development servers for cost reasons. Let's pick the application server, SQL Server Development 1. If you look at the dependencies other applications have to that service, you will clearly see that a production service is consumed. So that being said, if your project is about to decommission this service, you will most likely impact production services, which is gonna delay your project timeline for sure, because after that change caused some severity one incidents, and after you have brought back everything online, you still need to reevaluate your entire project plan because that might not be the only production application depending on your service. At the end of the day, your project timeline will be screwed. You might take more time, you might consume more money, and at the end, it will affect the entire planning. Another use case is related to mergers and acquisitions. And that specifically is a problem for service providers. And I can give an example from my past, more than 20 years ago, when a service provider had to take a decision whether or not to bid for an outsourcing deal. And that particular service provider had 2 weeks' time to analyze the environment, to understand how many servers we are talking about, how many application services in order to put a number on the offer. And the way we did it back then was to fly all representatives from all the sites to a central location. Everybody was equipped with Excel spreadsheets that were documenting the status quo on that specific site. And then these spreadsheets were used to make up a picture of that specific enterprise. And this is exactly what Mugato can do within 2 weeks, requiring absolutely no manual interaction. Because by collecting meta information from all the involved servers and using our behavioral analytics engine to conclude on how everything is connected to each other, you get that full picture of your enterprise, what is connected, where are the dependencies, without looking into a single spreadsheet. Another element that is important for due diligence is to know the unknown. And because we know whom every server is communicating with, we can split these communication partners into hosts on the internet, which means external connections, or we can categorize them into internal communication partners. That's typically assets sitting on your network, and we can conclude on unknown connections. Let me show you an example. We have here a number of servers with inbound connections that are all unknown to us. If we filter this down to a certain port, let's choose 445, which might indicate Windows file services, then we see how your servers are connected, or from where your servers are connected with. And we see here lots of IP addresses that are unknown, that do not match to the subnets that are configured in Active Directory, where nobody has an idea where these assets are, and it might give you an indication of a certain number of uncertainties that you did not have on your radar before. Another use case that highly depends from service dependency mapping and your understanding of what is connected to each other is disaster recovery. And in particular, that is important when you set up your disaster recovery plan and when you need to decide what needs to be moved first. And then you test it, and then eventually from year to year, you will adjust that plan. But initially, you need to decide what needs to be moved first. And this is, again, something where Mugato can help, because we know what depends from each other, including infrastructure services, as you can see here. We generate a plan where we categorize the different applications into transformation waves. And by doing that, we tell you exactly what groups of applications would have to be moved first in order to bring you most critical services up and running on a second data center. These were just 3 use cases, and there are much more. But I think we all agree that having an up-to-date list of your enterprise showing how the application services are connected to each other, what depends from each other, is key. It's really critical in order for you to take decisions based on facts and not on assumptions. Because we collect meta information from all your systems with minute granularity. Any change on your infrastructure, any communication change on a certain server will immediately impact the way how we show the dependencies between all your applications.